Okay, seepage tadi as mentioned earlier, the movement from the higher level to the lower level. Okay, whether through the dam, concrete dam, ataupun through the sheet pile. This is the sheet pile, sheeting, the kepingan, pile kepingan. Normally function as a retaining structure or to retain level between land dan juga water. So nak tahan that water, kita akan tanamkan sheet pile. But then we need to know lah, jauh dekat dalam, kat mana kita tanam the sheet pile, we need to estimate the quantity of the seepage. Nak ensure that in future tak ada issue due to the stability of the sheet pile. Okay, so normally we are using the flow net. Okay, flow net is the graphical representations of a flow of water in soil. Okay, so based on the flow net, we have the flow line and also we have the equipotential line. So once we have the flow line and equipotential line, so we can identify or determine the quantities of seepage. So which one is the flow line? Flow line ni this one. Okay, ini adalah flow line. Okay, yang smiley macam ni is the flow line, and then yang macam ni is the equipotential line. Okay, so this one is the equipotential line. Okay, alright. So there are few requirements, there are few rules to draw the flow net. First, antaranya we need to ensure that the intersections in between the flow line and equipotential line, the shape ni is about look like square field. Not obviously rectangular. We try to manage to get it more bentuk di dalam square, and the angle is likely to have 90 degrees, 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, this is handwritten exercise. Okay, kita tengok satu example. We need to draw a flow net for the seepage condition as shown and determine the quantity of seepage under the piles. Okay, so given the coefficients of mobility, which is K value, given the K value, so this is the dimension 5.5 meter, 12, 7, the depths of the sheet pile yang kita tanam dekat dalam, and we have the different levels 0.5 here and also 5 meter. So the head that cause to flow, yang menyebabkan berlakunya aliran air, maknanya air will flow from the higher level to the lower level, is H equal to 5. Mana dapat? 5.5 minus 0.5. So you will get 5 meter. So how to draw the flow net? Right. So first kali we need to redraw the structure, the sheet pile, and also the layer with suitable scale. So sama ada nak plot on the graph paper or on the A4 paper, make sure that all the elements, the structure tu sendiri dan juga layer tu muat dalam kertas yang kita pakai, fit within the paper, whether A4 or the graph paper. So use the suitable scale. For example, for 1 meter size, kita gunakan dia as a 1 cm. Maknanya 1 meter sama juga dengan 1 cm. So if we have the thickness 5.5 meter, is actually equivalent to 5.5 cm. Okay, we start with the sheet pile. Okay, you draw the sheet pile exactly as the question. Okay, and put the sheet pile in the middle. Letak, lukis dia dekat tengah-tengah dulu. Kalau you A4 paper, you landscape kan, you melintangkan. Okay, and then you put the sheet pile tu dekat tengah-tengah. Sama juga if you use the graph paper. Okay, alright. Okay, that is the sheet pile, and then follow the measurement. Kalau deep down tu dia tanam 7 meter, meaning that is 7 cm from the ground surface. Okay, daripada permukaan tu. Alright, and then tandakan juga we have 5.5 meter, the higher pressure or higher level of the water, and we have 0.5 meter for the lower pressure or lower level. Okay, alright. So that one also follow the scale, the scale. Kalau 5.5 meter meaning that 5.5 cm, 0.5 meter 0.5 cm. Okay, now we have the sand layer or the soil layer. Okay, 12 meter. So measure 12 meter and then you tandakan dengan satu horizontal line. Okay, then we can start to draw the flow net. Okay, we start with the flow line. Okay, we start with the flow line. Okay, you just estimate it. Okay, alright. Start with that one that close to the sheet pile. Okay, make sure that the gap is like the same. Jarak antara satu line ke satu flow line tu is about the same. Lebar dia or the gap tu lebih kurang sama. Sorry with the drawing, sebab I draw on the screen, so tak berapa nak smooth. Okay, and then make sure that you tak langgar the boundary yang dekat bawah ni. You tak langgar boundary bawah. Maybe kalau you lukis satu lagi, dia akan tak sama size. So ensure that dia tak langgar boundary yang bawah. Okay, and then kalau dah cukup, now kita continue with the equipotential line. Okay, you can start with the first one yang dekat sini. Boleh mula dengan yang ni dulu. Okay, and then yang lain akan follow lah. And also the gap tu is about the same sizes. Sebab kalau boleh kita nak nampak dia macam lebih kurang square kat sini kan. Nampak lebih kurang square. Okay, tak nak obviously rectangular. Kita tak nak dia obviously rectangular. Okay, and then kita habiskan all the flow equipotential line. And also be careful, tak nak lebih daripada boundary yang dekat atas ni, line ni. Okay, tak nak lebih daripada boundary yang tu. Okay, alright. So that boundary sebagai target line. Okay, now we have all the flow lines and equipotential lines. So we need to count. Okay, the flow line adalah laluan kat mana air tu akan bergerak from higher level to lower level lah. Yang ni basically air mengalir from the higher level. Air mengalir daripada sini. So we have 1, 2, 3, 4 and the last one. Don't forget the last one yang dekat bawah ni juga also counted as a flow line. So we have 5 flow line. And then with the equipotential line, okay, equipotential line you kena kira satu-satu bahagian. So this one is 1, 2, 3 up to 14 yang the last one, and also including the 15. So boundary yang dekat atas ni termasuk as a equipotential line. So now we have an F equal to 5 and D 15. So the next step, and also we have the H 5.5 minus 0.5, which is equal to 5 meter. So now we need to calculate the quantity of seepage. So by using this equation, so kita gunakan this equation. Q is the quantity, K coefficient, H head cause of flowing tadi yang kita kira 5 tadi, and F and juga ND. So given K, so kita ada H5 and F5 and also ND 15. Just masukkan. When we masukkan that, notice unit dia tak setara, different unit, mm dengan meter. So what we need to do, make it similar unit. So we convert the Q mm per second to meter. So kita dapat yang ni 7.2 exponent negative 6 meter per second. 1 meter equivalent to 1000 mm. So kita masukkan semua dalam equation. This is the K, this is the H and F and ND. And then bila you calculate, at first kita akan dapat 1.2 exponent negative 5 meter square. But then this is the quantity, so dia nak unit dia dalam quantity, volume, cubic. So mana datang lagi 1 meter is actually meter length. So this is the sheet pile tadi. So we have all the details yang lain. So the length is actually dia adalah arrangement. So dia ada length yang ke belakang tu lagi. So kita time dengan that length in unit meter. Okay. Alright. So this is the answer why we have meter cube per second. Okay. Thank you.